Okay, so I'm going to explain these now. Okay, so when it comes to it, I'm going to explain open circle, closed circle. Okay, there's going to be a difference between these. If it doesn't have a line under the inequality, we're going to have an open circle. If it does have a line, it's going to be a closed circle. Next thing is dotted line, solid line. Okay, dotted line, solid line. That's if it doesn't have a line under, it's going to be dotted line, does is solid line. This is just an explanation of everything that has to deal with inequalities just up front so that we can get through it. So, there's two things I want to show you about inequalities. First is just a normal problem. So let's say we have 7x. Yeah, okay, so yeah, let's go with 7x plus 3 is less than or equal to, I don't know, 5x plus 7. Okay, so you solve this just like you would any other problem, where this. Okay, so we solve this just like any other problem, but this is what I want you always to do. Always want you to make the left side the x house, and the right side the number house. What this means is we're going to get all the x's over here always, get all the numbers over here always. Okay, so first, what's in the x house that shouldn't be in the x house? Well, the 7x is in its house, so we don't have to deal with that. But the plus 3 does not have an x with it, so it's in the x house and it's uninvited. So we want to get rid of it. The only way to do that is to get rid of it is to subtract it. So we subtract it from both sides. This becomes 7x is less than or equal to 5x plus 4. Okay. Now, what's in the number house that shouldn't be in the number house? Well, the 5x. Now, we cannot multiply or divide till everyone's in their house, as I've said before. So that's what we're going to do is we're going to get rid of it by adding or subtracting it. So we're going to subtract it away since it's already positive. And then finally we're going to solve by dividing by 2 on both sides. Okay? Okay. So x is less than or equal to 2. This is where the number line comes in. Okay, I'm just going to put a 2 here. Now, do you see this line under it? That means that we're going to have a solid dot. So I'm going to put a little solid dot here. And this inequality sign, it's like an arrowhead. It looks like it's pointing to the left. So we're going to draw an arrow to the left. Okay? So now let me show you one. It's a little bit different. Let's give you 4x minus 5 is greater than, I don't know, 7x plus 10. Okay? So once again, x house is always going to be on the left, number house is always going to be on the right. So what's in the x house that shouldn't be in the x house? Well, the 5, so we're going to add 5 to both sides. Okay, so it's going to give me 4x is greater than 7x plus 15. Okay, next step is to get rid of the 7x because it's in the number house and it should not be in the number house. We're going to subtract 7x from both sides. So it's going to give me negative 3x is greater than 15. Last but not least is this negative 3 right here. Okay, so we're going to divide by negative 3. Now, there's something special that happens when you divide by negative. When you multiply or divide by negative, you have to flip the inequality sign, so it changes direction. So this is going to be x, negative 5. Instead of being a greater than sign, it's going to be a less than sign. So that's your final answer. Do you see how it flipped from that to that? And there's a reason why I always want the x on the left. We can only do this arrow trick if the x is on the left, so that's why we continuously try to get the x house on the left hand side. So once again, I'm going to put negative 5. This does not have a line under it, so it's going to be an open dot. And since this little thing looks like this, it's going to be pointing to the left. So we're going to put an arrow to the left. And that's the answer to that. Okay. Last but not least is an explanation of how to graph an inequality, and that's it. Okay, so y, let's say y is less than or equal to 1/3 x plus 5. To graph these inequalities, you first start with the y-intercept. It's always the number following the x. So plus 5. So I'm going to go up 5. 1, 2, 3, 4, 5. I'm going to put a little dot. Okay. My slope is then the rise over a run. So since it's positive, we'll go up 1. And then we'll go over 3. So I'm going to go up 1 over 3. Like that. Okay. Now, we're going to go back to what I said earlier. Whether or not we're going to have a dotted or a solid line. Well, if you notice, this sign is a less than or equal to sign, so we're going to have a solid line. So this is what it means. This means instead of making a dotted line, we're going to make a solid line right here. Okay? Otherwise, it would look something like this. It would be like dotted. That's what a dotted line would look like. But we're not done yet. The only last step is which side to shade. Okay? So, this is what you do. We're always using the test point 0, 0. So it's pretty easy to figure this out. Technically, here's a long-winded explanation. I would plug 0 in for x and for y. So it'd be 0 is less than or equal to anything times 0 is 0. So it's going to be 0 plus 5, which means 0 is less than or equal to 5. Okay? So this is our test point. The short-winded explanation is this. Do you see how there's, all you do is you replace the y with 0, you put a less than or equal to sign, whatever follows the x, you put that there, and that's a quick explanation. So this is the same thing to get, but it's just two different ways to get it. Okay? Now, we're going to look at this. Is this a true statement? Well, 0 is less than 5, so this is a true statement. Okay? And this is why we need to know whether it's true or false. Because if it's true, we have two halves. Okay? So we have top half, bottom half. Our test point is always here where the x and the y crosses. So we have to think to ourselves, okay, so if it's true, we're going to shade the half that has this on it. If it's false, we're going to shade on the half that does not have it. So since this is true, we're going to shade on this half. If it was false, we'd shade on the other half. Now, if you had other problems where you're going to have to graph two things. So let's say I had one line that looked like this, another line that looked like this. Okay? So we'll call this line 1, this is line 2. Okay? Now, let's say that line 1, when we did our little test point thing, this little thing up here, whether it's true or false, let's say that it was false and that line 2 was true. Okay? When we did it, line 2 was true, line 1 was false. Okay, so if we had line 1, it says false. Here's your test point right there, right? It's always going to be right there. Here's line 1. If it's false, we shade on the opposite side. So you're just going to pretend that you're just looking at just this line. There's two halves. There's the left and there's the right. Well, the test point's on the left-hand side. Since it's false, we want to shade on the side that does not have the test point, which would be this side. So you would shade the whole part of that side. So I'm just going to shade by doing this. This is me shading. Okay? Notice how I shade the entire side. I ignore line 2 and its whole thing. I'm just shading on the right-hand side of the L1. L2. That one's true. Okay? So it has two parts. If this is the line right here, it has the top part and the bottom part. Since it's true, the bottom part contains the test point. We want to shade on the bottom part that has the test point because it's true. If it was false, we'd shade the other side. But since it's true, we shade the side that has the test point. So I'm going to shade this. So there's one area, which is this bottom. If you think of this as 4 pieces, if you're 1, 2, 3, 4, where the lines are crossing, they create 4 pie pieces. This piece right here would be your answer set because it works for both line 1 and it works for line 2. And that's an explanation of how to figure out system of equations. Alright, thanks.